Hi friends, today we are going to learn fourth generations and fifth generations laptop power sequence. We are learning on this Compal motherboard. Okay, so this is Haswell processor, fourth generations, and this is my SIO, and we'll see the signals how they are coordinating with each other. So first we'll see this is my voltage sections where my adapter inputs and battery inputs goes inside. My adapter may be something 18.5 volt and battery 10.8 volt goes inside. So this out voltage is called the V in voltage. If it is both are connected, adapter and battery, then I'll get a adapter voltage out, that is 18.5 volt, and then this volt goes to the different department, different sections. So these are the pulse width modulator. These are the pulse. Here's a 2 pulse width modulator, 3 and 5 volt. Here are 2, 1 volt and 1.8 volt. Here is a 1.35 volt. Here is a 1.05 volt, and the last here are the 2 pulse width modulator for the CPU core and the graphics core. So these the gray color are the pulse width modulator. The input is adapter voltage is the input, and these are SIO KB9012 coordinating between all the sections, and here is a processor, and this one is a BIOS. So first this voltage goes inside, this 18.45 voltage goes inside, it goes to the different section, and this always volt send out the voltage, that is called the linear voltage, and this linear voltage goes to the SIO. This voltage is called 3 VLP. So this 3 VLP volt goes to the SIO get power on, and SIO send one signal that is called the EC on. So here we made a step. So P1, 2, 3, 4 is like a step. So we had to go like different steps. So first the voltage goes inside, then 3 VLP volt comes out, SIO get the power 3 volt, then SIO omit one signal that is called a EC on. In this red color, the red color that is a voltage, and this blue color it's a signal. Okay, so this EC on signal comes out from the SIO if the SIO is okay, and it goes to this always voltage. In this section we'll see later on the schematic diagram how this signal goes. What we'll do, we'll see now only. We'll go to the schematic diagram. So now we'll see on the schematic diagram. So this is a Compal motherboard, and the motherboard number is LA-A621. This is a 38-page diagram. So first of all we'll go to the voltage sections, that is on the page number 30. This is my voltage sections. Okay, so we'll see how the voltages flow in this circuit. So here is my adapter input, 18 volt goes inside, and these are the MOSFET, and this is a controller chip V in, this number is BQ2472. These are the MOSFET. So my 18 volt goes from cross this MOSFET, then cross this second MOSFET, and comes here this current sensing resistor. This is a 0.2 ohms resistor, and you will see my adapter voltage will be here. You should check, you can check 18.5 volt here. If the 18.5 volt is not coming here, then the possible fault could be this 2 MOSFET, or this chip is not driving to this MOSFET. Okay, so this is my first section. So voltage should come here, and this voltage 18 volt goes to the different departments. So we'll see second, that is my always voltage, that is on page number 31. So this is my always voltage section. So you can see here, so there are two sections, section this, and this is another sections. Okay, so in this first sections, this chip number is This chip number is location is PU401. The chip number is SY82088BQNC. This is my 3 volt pulse width modulator. My 18 volt goes to pin number 8. Okay, and my 18 volt goes to pin number 8, and this pin number 5 is a LDO. This is a linear output. My 3 volt comes out from this pin, and this voltage goes to SIO. Okay, this 3 volt goes to the SIO power on. Now in these chips there are two sections. One is a linear voltage and another is a pulse width modulator. So the linear voltage, as soon as I give the input voltage, the linear voltage immediately comes out on the pin number 5. But for this pulse width modulator, these chips require an enable signal. Without enable signal, this section can't work. So in this section there are pulse width modulator and two MOSFETs also inside. So once this chips get the enable from this pin number 1, started triggering, and this pin number 10, the pulsating AC voltage comes out, goes to this coil and this 3 linear voltage, 3 pulse width modulator voltage out to here. Okay, so same way here also you can see here is my 5 volt, same. In here goes the 18 voltage inside, pin number 7 linear voltage out. When you get the enable signal, this 5 volt comes out. So we can see in this schematic diagram how it's work. Now we'll go again back to our concept. So we see how this 3 volt and 5 volt comes out. When the sections is working fine, he send one omit one signal that is called the SPOK. He send one signal that is called the SPOK, and this goes to the SIO. As well as this SPOK signal goes to this pulse width modulator also, this 1 volt and 1.8 volt pulse width modulator also. So once this SPOK signal comes out, he get enable signal to this 1 volt and 1.8 volt, and 1 volt comes out. This pulse width modulator 1 volt and 1.8 comes out, and this 1 volt and 1.8 goes to processor. So this is step number 6. So this is before powering on. Now we'll turn on the power button. So this is my power button, step number 7. So here is a 3 volt. As soon as I press a power button, it goes to 0. When I release button, again it goes back to 3 volt. So step number 7. So as soon as I press a power button, SIO emit one signal that is called the RSM RST. It's sent to the processor, because the PCH and processor is in single chips. So it send one RSM RST, the resume and research, 3 volt comes out. Then within a 10 milliseconds of durations, he send another signal that is called a PM power button at step number 9. So if my processor is okay, and if everything is fine, the processor send reply him a 2 signal. So now the entire power supply is turned on. He want to turn on, power supply is turned off, but he now want to turn on. So SIO send 2 signal that is called a SLP S3 and SLP S4. That is called a slip mode 3 and slip mode 4. So he omit the 2 signal, that is a step number 10 to the SIO. Once SIO received this 2 signal, that means previously it was a 0 volt. As soon as he send this signal, so here will be 3 volt. So as soon as SIO received this SLP3 and SLP-S4 signal, SIO omit one signal that is called a system on to this pulse width modulator. In this pulse width modulator, when this he received this system on signal, this enable signal to the 1.35, this 1.35 goes to my DDR3 LRAM. Okay, so this 1.35 voltage will be generated and goes to the RAM. and its power good goes to the CPU, that is called a DDR power okay. That means the RAM got the power. This signal means that he is saying to the CPU that RAM got the power. That is step number 13. The next step is VR on signal, that is a step number 14. After system on, SI omit one signal, that is a VR on signal, to this V core section, that is a VRM section. In this VRM section there are two sections, V core voltage and graphics core voltage. This is step number 15 and 16. There are two voltage will be generated, and that voltage supposed to be 0.7 to 0.9, in between 0.7 volt to 0.9 voltage. So the two different voltage will be generated on the V core section, and that supply goes to the processor. That is step number 15 and 16. And then this sections, when it's okay, he send one signal that is called a V gate. The V gate signal means my entire CPU core section is working fine, and it goes to the SIO. After SIO got the signal, SIO send another signal, that is SUSP, that means suspend on. In this, you can see in this there are some circle we are made. So here are MOSFETs. So this signal name is called suspend. Suspend means the voltage will be generated already here at this point, but as soon as you trigger this MOSFET, that's step number 18, this voltage will be released to other side. Suppose here is a drain, and this one is a gate, and this one is a source. So as soon as the gate triggered to this MOSFET, the drain voltage pass to toward the source side. So same way here, this 3 volt always become the 3 volt suspend, 5 volt always become the 5 volt suspend, 1 volt always become the 1 volt suspend, and 1.8 and 1.35 like that. And finally he turn on this 1.05 voltage also, that is a system voltage 1.05, and this voltage goes to the processor. That is a step number 18. Okay, so in this way we can see how this entire sections works. Yeah, at the step number 19, the all voltage will be generated, and it goes to the different sections to the respective component. And this in step number 10, SI omit one signal, that is called a KB reset. Step number 20, then at 21 he send one signal, that is called a PMC core okay, power okay. That means the power okay signal. This signal means your entire power streams is okay. It's sent to the processor. If you check this signal, if it is here is 3 volts, that means my entire power stream is okay. So after 21 steps, then 22 steps, that is called the DDR power okay. And finally when CPU received this 20 power okay, finally CPU omit one signal, that is called a PLT reset, that is a platform reset. Is reset the entire motherboard including RAM and your network or audio or whatever it may be. You reset and this signal you can check on this SIO, or you can check on the Wi-Fi card port also. And finally at step number 24, SIO the CPU start reading the BIOS. So in this way we can see how this sections work. Now we're going to see on the schematic diagram. Okay, so we'll go to the SIO page, that is on page number 23. Okay, so this one is SIO. And you can first you have to check pin number 9. Here should be a 3 volt. This SIO is a U28 location, and this SIO number is KB9012. Okay, we'll see the pins of the SIO. This pin number 9 is a VCC pin. You have to check a 3 volt here. That is my first steps. Then the next signal you have to check, that is called a EC on, that is on 112 pin. This is a EC on. When SIO received the signal, if it is SIO is okay, he send one signal that is called a EC on, that is pin number 112. Then SIO turn on both the 3.3 and 5 volt, and finally SIO received a SPOK signal. You can see on this side on pin number 25 SPOK signal. When the SIO received this SPOK signal, that means my always voltage is turned on. SIO, my always voltage, that means my 3.3 and 5 volt is working fine if you received this signal at pin number 25. Then the next is my 1 volt and 1.8 volt turn on, and then we have to press the power button. The power button is my 114, this pin 114. This is my power button. This is my power button. As soon as you press this to ground and release, one pulse is generated, 303 pulse to the 111 pin, and then SIO omit one signal that is called a RSMRST pin number 100. If it is my SIO and the EC bias is okay, then here after power button press, here you should get a 3 volt. If you are not get a 3 volt at this pin after pressing a power button, that means my possible fault could be SIO or my EC bias. Pin number 100. The next is PM power button, that is the post power button or digital power button. On a pin number 106, it goes to the CPU saying this power button is press. Then SIO processor send two signal that is called slip mode 3 and slip mode 4, SLPS3, SLPS4. From the processor you can see the arrow, it goes to pin number 6 at the SIO, and pin number 14 it come from the processor. Then if after receiving this pulse, SIO started turning on the different powers from different power streams. So he first turn on the system on signal, that is pin number 95. You can see pin number 95. This is called a system on signal. Here it was 0. Now after receiving this SLPS3, SLPS4 signal, this pin goes to 3 volt. That is system on signal is turned on. Is turn on the all the 1.35 voltage and all. Then 121, this is a core voltage VR on signal. Sorry, is turn on this VR on signal, and here my CPU core voltage will be generated, that is CPU core and graphics core voltage will be turned on. Then the next is V gate signal. V gate signal means pin number 97, that is a V gate. You can see V gate. One sec. Yeah, this one, pin number 97, V gate. Here it was a 0 volt, but when my core voltage turn on, that's VRM section is working fine. If my VRM section is working fine, then here I'll get a 3 volt. If I'll get a 3 volt here at pin number 97, that pin is called the V gate. That means my VRM section is working fine. Okay. The next is SUSP signal, that means suspend on, pin number 116. Pin number 116, suspend on. At this pin, the all power streams mode transfer always to suspend. And then KB reset, pin number 2, SIO send a KB reset signal to the processor, that is an interrupt. And then pin number 21, 32, pin number 32 is my PMC power okay, that means the all powers are okay. Pin number 32, we'll see where it is. 32, wait, yeah, this one, This is my pin number 32, that is called a PCH power OK. And SIO sent to the PCH, or it's called a CPU, that is called a PCH power OK, or you can say the another name is a PMC core power OK. The PMC core power OK or the PCH power OK, that means my entire power stream is OK, and now proceed for the reset signal, that is a PMC reset. And finally CPU generate a reset signal that you can check on the SIO also. This one is my PLT reset. Here you will get a 3 volt. If my processor is working and he omit one reset signal, here you will get a 3 volt. So in this way we seen how this 4th generation and 5th generation power stream work for the Compal laptop motherboard. Thank you very much.